Hello everyone. Today we'll be starting with the course on mathematical methods for economics. That is the course for semester 2 Delhi University Economics Honors. Before starting with the course, I would like to introduce myself. My name is Katyayani. I have done my economics honors from Lady Shri Ram College, University of Delhi. Then I went on to pursue my master's in economics from Delhi School of Economics, and since then I have been teaching in the Delhi University. So let's start with the course. Before starting the course, I would like to introduce you to the readings or the syllabus that we'll be following throughout the course. So you can see on your screens that these are the topics that you have to cover. The basic reading would be Sitzeter and Hammond, which is the 2002 edition, right? The first unit being linear algebra, where we'll be covering topics like vector spaces, matrices, determinants, and so on. Some of these topics you might have already done in your 11th and 12th standard, right? But here basically we'll be studying these topics from the angle of economics, right? How do we use these concepts for economic analysis, for micro modeling, and so on. The chapters that we'll be following will be chapter number 12, 13, and 14 from Sitzeter and Hammond. Then we'll move on to unit 2, where we have different topics like functions of several real variables. Before this, we have done functions of only one variable. Here, we'll be doing functions of more than one variable. Right, we'll be studying about the characteristics and the applications of those functions. What are the second order derivatives? What are their properties? What is the implicit function theorem, and so on. Right, and for this we'll be doing chapter number 15 and 16 of Sitzeter and Hammond. And lastly, the third unit is about multivariate optimization, where we'll be studying about the different types of sets like convex sets, concave sets, their geometric properties, what are convex function, what are quasi-convex, what is unconstrained optimization, and so on. And then we'll be seeing all of that geometrically as well, right? For that, we'll be doing chapter number 17 of Sitzeter and Hammond, again, which is the second edition, right? So the Delhi University also prescribes the hours needed for each unit, so it's 15, 15, and 15 hours. That is the amount of classroom learning that you need for one particular unit, right? So without much of a delay, let's start with this with the first unit. So today I'll be starting with the topics of vector spaces. What are vector spaces? What are the geometric properties, and so on. So let's get started. So let's start number 12, that is called linear algebra, vectors and matrices. So first of all, we'll try to introduce what are vectors, right? So you can see here what are vectors. So vectors are, suppose you have an industry in which you're producing different types of outputs, right? So you have some industry जिसमें आप अलग-अलग type के outputs बनाते हैं. Suppose different products बनाते हैं V1, V2, V3 and so on till Vn, right? तो आप n products बनाते हैं. Up, you have to tell me what are the prices of each of these outputs and then what are the quantities you are selling me, right? So इस टाइप की चीज़ों को, इस टाइप के ordered pairs जब आपको बताने होते हैं, then vectors come very handy. So you can write that the price vector here would be P1, P2, P3 and so on till Pn. इसका क्या मतलब है? That the price of the first good that you're producing in your industry, that is V1, would be P1, then price of the second good would be P2, price of the third good would be P3 and so on, and the price of the nth good would be Pn. The quantity that you're selling for each good would be, say, Q1 of the first good, Q2 of the second good, and Qn of the second good, right? So when you write such a thing in an ordered pair, where not only the components of that ordered pair matter, but also the order matters, those are called vectors. राइट तो यहाँ पे सिर्फ आपके कंपोनेंट्स क्या हैं उसमें वो सिर्फ वही मैटर नहीं करते पर उनका ऑर्डर क्या है दैट ऑल्सो मैटर्स such an ordered set of number is called vectors, right? So we can formally write down what is the definition of a vector. A vector would be an ordered set of numbers where not only the element it contains matter, but also the order in which they appear. Okay, the order in which they appear matters, right? So here, अब यहाँ पे आप उस ordered pair को दो तरीके से लिख सकते हो. So there are two ways of writing that ordered pair. On the basis of that, we have characterized our vectors into two types, right? तो हमने अपने vectors को दो तरीकों में divide किया है. पहला होता है row vector, right? Another one is the column vector. So as the name suggests, नाम से ही पता चल रहा है आपको, if I write my ordered set of numbers in the form of a row, right? अगर मैं लिखती हूँ P1, P2 and so on till Pn, then such a vector would be called a row vector. If I write the same thing in a column, right? P1, P2, P3 and so on till Pn, then such a vector would become a column vector, right? So there are two types of vectors, row vector and column vector, right? Vector को जब भी हम denote करते हैं, you always write it in bold, right? So you will say that A is my vector, तो आप उसको हमेशा bold में लिखोगे. So A here is suppose A1, A2 and so on till AN. Then you would write A here is the vector, right? And the components, तो A1 यहाँ पे A2 ये सब क्या है? These are all called the components. These are all called the components of a vector. So A1, A2, A3 and so on till AN, these are all called the components of a vector, right? So A1, A2, A3, AN, they are called the components of vector, right? The number of elements in a vector also decide whether it would be called a one vector, or whether it would be called a one vector, two vector, three vector, four vector, five vector and n vector. So here if you have n elements in or n components in a vector, then such a vector is called an n vector, right? Or it is also called n tuple. So if there are four elements in a vector, then it would be called a four vector or a four tuple, right? So this much is clear. So whenever you have an ordered set of numbers, right, it's become easier to denote it using a vector, right? And in the vectors, the order matters as well as the elements matter, right? So now let's see what does it mean geometrically, right? Geometrically, what do you mean by a vector? So let's look at the geometric interpretation of vectors, right? So vector जो है ना वो एक Latin word है. So it's a Latin word और इसका मतलब होता है carrier, right? Carrier या फिर the one who carries. तो vector basically हमें position बताता है. Suppose I have my xy plane here, x axis, y axis, and initially suppose I am at point P, right? Whenever I write a vector A, so A here is in bold because I am writing about vectors. Whenever I write a vector A1, A2, इसका मतलब है I am moving A1 distance on the x-axis and I am moving A2 distance on the y-axis. So if I am starting from point P, or P के coordinates are suppose P1 and P2, right? Then it means that I will be moving A1 distance. Suppose this is A1, so I am moving this much distance, A1 distance on the x-axis, and then I am moving A2 distance, suppose this much is the A2 distance, I am moving A2 distance on the y-axis, right? And then suppose I reach point Q, right? So the vector A1, A2 takes me from point P to point Q. So as the name suggests, vector here is a carrier, right? मुझे carry करता है from point 1 to point 2. So I can write this vector as the geometric vector PQ, and the arrow here denotes that I am moving from point P to point Q. So the geometric interpretation of a vector is that it is a directed line segment, right? तो vector क्या होता है? Vector is nothing but a directed line segment moving from point P to point Q. Why is it called directed? Because here the direction also matters. I'm starting from P and then going to Q, right? Now, one thing that you have to keep in mind is that suppose the starting point was somewhat different. It was not P, but this time suppose it was, so we were in the xy plane, and then again this time it was not P, it was something called, say, P prime, right? Different from P. अगर P यहाँ कहीं है तो P prime इससे अलग कहीं और, it's a different point, right? Now again, if I'm talking about vector A being A1 A2, right? दोबारा से A1 A2 का मतलब है I am moving A1 distance on the x-axis and then A2 distance on the y-axis, and suppose now I am reaching a point Q prime, right? So the geometric vector here would be P prime Q prime, and we are moving from P prime Q prime, right? Now this geometric vector PQ is equal to the geometric vector P prime Q prime. Why are they equal? They're equal because I am moving the same distance on the x-axis and same distance on the y-axis, and the direction of the movement is same, right? So two geometric vectors are said to be equal. यहाँ पे PQ और P prime Q दोनों equal है. यहाँ पे आप देख सकते हैं, यहाँ पे हम P से Q पे move कर रहे थे, पर P से Q पे जाने के लिए मुझे horizontally A1 distance cover करना पड़ा, vertically A2 distance cover करना पड़ा, right? Here again, when I was at a different point, say P prime, again I am covering a distance of A1 on the x-axis and a distance of A2 on the y-axis. So जो मेरा geometric vector है और right, उसका जो मेरा magnitude है और उसका direction है, that is same. So we can say that these two vectors are equal to each other, right? These two vectors A1 A2 take us, so here A1 A2 on A1 A2 would be same vector. तो चाहे मैं P से P Q जाऊँ या फिर P prime से Q prime जाऊँ, A1 A2 vector same रह रहा है क्योंकि वो मुझे same distance cover करा रहा है in the same direction, right? So that is geometrically how you can think of vectors in your mind, right? तो अगर आपको पता है कि P जो था मेरा point, उसके coordinates थे P1 P2. Now what will be the coordinates of point Q? You can see from here that now Q would be y-axis पे already I was P2 distance away from the origin. Now I have moved A2 ऊपर और, so now it has become P2 plus A2, right? On the x-axis you can see I was already P1 distance away at point P. When I go to Q, मुझे A1 और चलना पड़ेगा, so it becomes P1 plus A1. Right? So what will be the coordinates of point Q? It would be P1 plus A1 on the x-axis and then P2 plus A2 on the y-axis, right? So this is how you get the coordinates of the new point Q when you move from point P to Q using by vector A, that is A1, A2, right? So that is how you interpret a vector geometrically, right? Now let's look at some of the operations of some vectors, right? कुछ operations होते हैं vectors के ऊपर. You can add two vectors, you can subtract two vectors, you can find out whether the vectors are equal or not, you can multiply the vectors with a scalar and so on. So let's see कि इनको हम कैसे operations कैसे कर सकते हैं vectors के ऊपर, and then let's see geometrically how can we interpret these vectors, right? Operations on these vectors. So the next topic that we'll be doing would be the operations on vectors, right? So there are different types of operation. First operation being equal vectors. When can you say that two vectors are equal to each other, right? When can you say that A, suppose एक vector है A, एक vector है B, I am denoting them by bold letters A and B. बोल्ड क्यों लिख रहे हैं? बिकॉज वेन एवर वी आर डिनोटिंग अ वेक्टर वी ऑलवेज राइट इट इन बोल्ड, राइट? सो सपोज दो वेक्टर्स हैं ए और बी, दे विल ए हियर सपोज इज a1 a2, एक n वेक्टर है a, and then b is again of n vector b2 b3 and so on bn. I can say that these two vectors are equal if and only if a1 is equal to a2, a1 is equal to b1, a2 is equal to b2, and then so on till an is equal to bn. That is, the corresponding elements are equal to each other. Only then I can say that the two vectors are equal to each other. So what do you say? The corresponding elements have to be equal, right? Or the corresponding components have to be equal to each other. Only then I can say that the two vectors are equal to each other, right? तो suppose example लेके देखते हैं. Let me give you an example. Suppose आपके पास एक vector है 1 minus 1 2. Can you say that this vector is equal to minus 1 1 and 2? No, they are not equal. Why? Because 1, the first element here in the first vector is 1, whereas the first element in the second vector is minus 1. So they are not equal. So these vectors are not equal to each other. तो सिर्फ components क्या है वो matter नहीं करता, उनका order क्या है that also matters in a vector. Let's take another example. Suppose एक वेक्टर है आपके पास 1 1 2 2, दूसरा वेक्टर है आपके पास 1 1 2. Can you say that these two vectors will be equal? No, they are not equal क्योंकि यहाँ पे order ही same नहीं है. So this is a 4 vector, this is a 3 vector. They cannot be equal. Both of them have to be of the same order. The vectors have to be of the same order. अगर ये 4 vector है first वाला, the second one has to be 4 vectors, and then the second condition is that their corresponding elements have to be equal. So this is it. Equal vectors क्या होते हैं? That is the first operation or the on the vectors, right? Now let's look at the second property of the vectors, that is, or the operation, that is the sum of vectors. So suppose मेरे पास दो vectors हैं a and b, and I have to add them, right? So this is a and b, and suppose मेरा a is a1 a2 a3 an plus b1 b2 and so on till bn. I have to add these two vectors, right? तो जब मुझे इनको ऐड करना है तो a1 I will be adding the corresponding elements. a1 would be added to b1, a2 would be added to b2, a3 would be added to b3 and so on. So the sum here would be a1 plus b1, a2 plus b2 and so on, an plus bn, right? This is how you add two vectors. This is the sum of two vectors, right? Now let's see geometrically sum हम कैसे निकाल सकते हैं दो vectors का, right? So suppose I was in the xy plane and one of my vector was vector a, which was like this, and then another vector was vector b, like this, right? So it was a1 a2, and this vector b was, the coordinates were b1 and b2. So here what is happening, the vector is taking us from origin to this point, right? So we are moving from here to here. This is vector a, and what is vector b doing? Vector b is taking us from origin to this point, right, by moving b1 distance on the x-axis and b2 distance on the y-axis. What if I add two vectors, these two vectors? What if I add a1 plus b1? What would happen, right? As I told you, I have to add the corresponding elements, right? So if I add a and b, I'm so sorry, if what happens if I add a and b? So a plus b, इसका मतलब है I have to add the corresponding elements, a1 plus b1 करना पड़ेगा, and then a2 plus b2, right? So if I add a1 and b1, I will be somewhere at a point like this on the x-axis, right? X-axis में मैं कहीं इतना distance I have to cover, right? And then if I have to add a2 and b2 on the y-axis, I have to cover somewhat this much distance, right? So I will be somewhere at this point, right? So मैं यहाँ पहुँच जाऊँगी. So what does it tell you? that you're moving from here to here. So this is the vector a1, a vector a plus b, right? So the vector a plus b takes you from the origin to this point, when vector a takes you from origin to point a, suppose, and then b takes you from point a origin to b, and then a vector a plus b takes you from origin to point c. This is how you can see geometrically what do you mean by addition of two vectors, right? Similarly, addition की जगह पे आप subtraction भी कर सकते हैं, right? अगर आपके पास दो vectors हैं a और b, you have to subtract b from a. So what you will do, you will subtract b1 from a1, b2 from a2, and so on till bn from an, right? This is how you will write down the subtraction of two vectors. If I am subtracting the same vector, अगर मैं a में से a को ही subtract कर रही हूँ, what does it mean? a1 minus a1, a2 minus a2, and so on till an minus an, which means that you have a zero vector, right? So here you can write this as a bold zero, right? Zero, bold zero being a zero vector of order n, right? This is how you subtract two vectors. Why is this beneficial? For example, आपको एक industry है आपकी पूरी, उसमें there are two firms, right? There are two firms industry में, there is firm 1 और दूसरी firm है there is firm 2, right? आपको पता लगाना है कि suppose firm 1 produces n products, q1, q2, q3, qn is being the quantity of those n products. तो जो first firm है वो q1, q2, q3 करके n products बनाती है, and this is the quantity of those products, right? Similarly, second firm है वो भी कुछ quantity बनाती है, let it be d1, d2, and so on till dn, right? Now you have to tell me what is the total product or the total amount of n products produced in the market or in the industry. So what will you do? What is the total of these n firms? So you will write it as q1 plus d1, q2 plus d2, and so on till qn plus dn. So यहाँ पे what is this first component? q1 plus dn being what is the total output of the first type, total output of the first type of good. Then what is the total output of the second type of good produced by both the firms? Then qn plus dn is what is total output of the nth good produced by both the firms, right? So whenever you have to find out such things, you can take help of vector addition in that cases, right? So this is how you can visualize it in an economic scenario, right? Then after the sum of vectors, you can have another operation called the third operation, which is called the scalar product, right? So the scalar product here means that if you are multiplying your vector with a scalar or with a number, so you're scaling up or scaling down your vector, that is called the scalar product. So suppose आपके पास एक a vector था, right? A being a1, a2, and so on till an. Now you are multiplying it with a scalar t. So t is a scalar. Scalar means it's a constant number or it's a constant number, right? If you have to multiply your vector with t, then what will you do? You will multiply each component with t. So ta1, ta2, and so on till tan, right? इसका इंटरप्रिटेशन कैसे है? सपोज आपके पास एक प्राइस वेक्टर था, यू हैड अ प्राइस वेक्टर इन द इंडस्ट्री, राइट? सो P1 क्या था? फर्स्ट प्रोडक्ट का प्राइस, P2 क्या था? सेकंड प्रोडक्ट का प्राइस, एंड सो ऑन Pn क्या था? थर्ड प्रोडक्ट, nth प्रोडक्ट का प्राइस, राइट? नाउ द गवर्नमेंट सेज और ऑल द फर्म्स इन द इंडस्ट्री डिसाइड कि हम अपने अपने प्राइसेस जो है वो डबल कर देंगे, राइट? सो व्हाट विल बी द न्यू प्राइस वेक्टर? द न्यू प्राइस वेक्टर वुड बी, so this was P, right? New price vector would be 2P. So 2P मतलब फर्स्ट इंडस्ट्री का भी प्राइस बढ़ गया है, राइट? सेकंड का भी बढ़ गया है, थर्ड का भी बढ़ गया है और nth का भी बढ़ गया है. So when I am writing 2p, I am multiplying my vector with a scalar, with a number, a constant number, then each component of that vector gets multiplied with that number, right? इसको ज्योमेट्रिकली कैसे देख सकते हो आप? सपोज पहले आपके पास एक वेक्टर p था, this was vector p, right? You were moving p1 distance on the x-axis and p2 distance on the y-axis, x and y. See, whenever I'm showing it graphically, I'll always be using a two tuple or a two vector. Why? क्योंकि whenever I'm showing it, it has to be a 2D, two-dimensional figure, right? और two-dimensional figure में xy plane में मैं आपको सिर्फ दो components ही दिखा सकती हूँ वेक्टर के. तो यहाँ पे मेरा वेक्टर है p is equal to p1 p2, right? अगर मैं बोलती हूँ कि I have to find out 2p, इसका क्या मतलब है? It will become 2 times p1 and then 2 times p2, right? तो नया वेक्टर जो होगा मेरा वो क्या हो जाएगा? डबल ऑफ दिस. p1 का डबल p2, right? And p2 का डबल 2p2, right? So it would be this. So the new vector would be this, right? So you can see that whenever I am multiplying the vector with a number, that vector, the direction remains the same. आप देख सकते हो direction वही है, सिर्फ उसकी length जो है वो double हो गई है. तो if I am doubling the vector, the length of the vector doubles here geometrically, you can see. अगर मैं इसको 3p कर देती हूँ तो the length would become triple, यहाँ तक आ जाएगा, right? And so on. What if I take the half of this vector, right? तो half क्या हो जाएगा? This. So 1 by 2p, right? So this would be the vector. So I can scale up, I can scale it down, right? So the length of the vector only changes, the direction remains the same when I multiply it with a scalar, right? So that is the scalar product of vectors, right? Now let's look at the fourth property. Which is the linear combination of vectors. So linear combination of two vectors. Right? So suppose there is a vector A and there is another vector B, right? A being A1, A2 and so on till AN, or B अलग vector है B1, B2 and so on till Bn, right? Suppose I'm multiplying it with two vectors. I'm multiplying it with 2, I'm multiplying it with 4. So, and then adding them. So what does it become? It becomes 2a1, 2a2 and so on till 2an plus 4b1, 4b2 and so on till 4bn. And then I can add them and get 2a1 plus 4b1, 2a2 plus 4b2 and so on till 2an plus 4bn, right? So such a linear combination of two vectors I can find using the linear combination of two vectors, right? So these are certain operations I can apply on two vectors. I can first multiply the vector with a scalar and then add these two vectors, and what does that become? It becomes a linear combination of two vectors. Why do we call it linear? Because I'm not taking the vector to a power, right? I'm just keeping the power of the vector as one. So this is a linear combination of two vectors, right? Again, you can show it graphically. First you will scale up the vector and then you will add those two scaled up vectors, and then you will be able to show it geometrically, right? Now after the operations on the vectors, let's look at some of the rules of addition and multiplication by scalars on a vector. So rules of addition and multiplication on vectors, right? So the first rule being that a plus b plus c here is equal to a plus b plus c. So what we are doing here is, first I'm adding two vectors a and b, and then I'm adding c to the sum of the vectors that I've obtained and it has to be equal to, I add the two vectors b and c first and then add that sum to a, right? So what is this property called? You've seen this property before. This is called the associative property, right? This is called the associative property of addition. So that applies to vectors as well. So it does not matter कि पहले आप a और b को ऐड करो, फिर c को ऐड करो उसमें, या फिर पहले b और c को ऐड करो and then a को ऐड करो. The order here, the order of addition here does not matter. So this is called the associative property of vectors, right? And then the second property is a plus b is equal to b plus a. So दो vectors हैं a and b. If I add a and b or I add b and a, it means the same thing, right? So you know that addition is commutative. So it is commutative even in vectors. So that is called the commutative property, right? Then the third property is, if I add a zero vector to a vector, you get the vector itself, right? So same, so zero is the, so here if I add a vector 0, so 0 is the identity of the sum here in the vectors. Okay, then if I subtract a vector from itself, I will always get the 0 vector, right? Then the fifth property says that if I'd have two scalars alpha and beta, if I have two scalars alpha and beta, and I add them and then multiply it with the vector a, or I multiply it with a vector a and then multiply beta with vector a and then add them, I will get the same result. So that is the fifth rule of addition and multiplication by scalars in vectors. The sixth rule says that if I have two vectors a and b and I add them and then multiply it with the alpha, or if I multiply each of the vectors with alpha and then add them, I will get the same results, right? The next property is, if I multiply a vector with beta and then multiply it with alpha, or I multiply the two scalars and then multiply it with the vector, I will get the same result. And the last property being, अगर मैं एक 1 से अपने vector को multiply करती हूँ, I will get the vector itself, right? So at the identity of multiplication is 1, the identity of addition is 0 here, right? Even in the case of vectors. So let's see if we can do a question on the topics that we have studied till now. So this is chapter number 12. Let's do a question from exercise 12.2 of your book Sater and Hammond. So let's do a question. Let's look at question number. So let's solve question number 7 from exercise 12.2 of your book. So it says that solve the vector equation. Solve the vector equation for x minus 7a is equal to 2x plus 8b minus a for x in terms of a and b. So your x here is a vector, a is a vector, b is a vector. The question says that you have to solve this equation for x in terms of a and b. So let's see how to do this on the basis of the operations that we have learned till now. So you know that we want to find out the value of x. So what you need to do is, so let's first write down the equation here. So let me do the solution for you. The equation already is 4x minus 7a is equal to 2x plus 8b minus a, right? So I want to get rid of the 7a from the LHS. So what I can do is I can add 7a on both the sides. So adding 7a on both sides, I will get 4x minus 7a plus 7a is equal to 2x plus 8b minus a plus 7a. So this becomes a 0 vector, right? So this I can ignore the 0 vector. When I subtract a 0 vector from 4x, it would be 4x itself. So I will get 2x plus 8b, and then minus a plus 7 would be 6a, right? And then I can write, and now I want this 2x to be on the LHS. So what I can do is I can subtract 2x from both the sides, so that I get 4x minus 2x, and then 2x minus 2x plus 8b plus 6a. So now I will get 2x on the LHS, and then this becomes a 0 vector, and then 8b plus 6a, right? Now I can multiply this by a scalar 1 by 2, so that I only have x on the LHS. So I would get x is equal to, multiplying by 1 by 2, I get this as 4b and this as 3a. So x would be equal to 4b plus 3a. So this is how I can solve for my vector x in terms of vectors b and a. You can see that this is very similar to the usual algebra that you have done till now, right? In your 7th, 8th standard, these simple equations that you used to solve for algebra, we are using the same techniques, but then you should keep in mind that these are based on the properties or the operations or the rules of operations of the vectors that we have studied, right? So I can add a vector, I can subtract a vector, I can multiply it by a scalar, and I'm using those properties to arrive at the value of vector x here, which comes out to be 4b plus 3a. Right? So this was question number 7 from your book, from exercise 12.2 of Sitzater and Hammond, and you'll have similar exercises, similar questions in that exercise, which you can try, right? So what we'll be doing here would be that we'll be discussing the topic first, and then try to solve some questions based on that exercise, based on those topics from the exercise of your book Sitzater and Hammond. And then once we are done with the chapter, what we'll do is we'll cover some past years questions from that chapter and do it here with you in class. So it will not be possible to do all the questions, but then I would want to do 1 or 2 questions from each topic, so that you get an idea of what type of questions are actually asked in the exam, right? So we've done one question from 12.2, and then we've also covered the geometric interpretation of our vectors, which is 12.3 in your book Sitzater and Hammond. And we can do one question from 12.3, so that you get an idea of what type of questions you can expect from geometric interpretation of vectors. So let me give you a question. So this is exercise 12.3, question number 2. The question number 2 says that let A is equal to 3, 1 be a vector, and B is equal to -1, 2, right? We have defined a new vector x as the linear combination of these two vectors. So I told you how do you get the linear combination? When you multiply each of your vector with a scalar and then add the two vectors. So suppose I multiply my first variable a, first vector a by 1 by lambda, and then add it to lambda times b, right? So x here is a linear combination of vectors a and b, and then it asks you in the question, in the first part it says compute x when lambda takes a value 0, lambda takes a value 1 by 4, takes a value 1 by 2, 3 by 4, and 1, right? So compute karna hai humko. Let's compute first, and then you have to illustrate it also. So let's see what happens here. So when lambda takes a value 0, what happens? So case 1, when lambda is equal to 0, right? So let me use another pen, a color pen here for solution. So when lambda takes a value 0, what happens? Your x is nothing but a itself, right? When lambda takes a value 1 by 4, then what happens? When lambda takes 1 by 2, what happens? And then when lambda is 3 by 4, what happens? And then finally, when lambda is 1, what happens? So you can see here, when lambda takes a value 1 by 4, this thing would become, x would become 3 by 4 times a plus 1 by 4 times b, right? When lambda takes a value 1 by 2, then it would become half of a plus half of b. And then when lambda takes a value 3 by 4, x becomes 1 by 4 times a plus 3 by 4 times b. And then when lambda takes a value 1, x becomes b, right? So let's see it geometrically. So it's asking you to illustrate it geometrically. So let's try to plot it. So let's try to plot these points on the xy plane, right? This is the x-axis, this is the y-axis, right? Suppose point A here is given to me as 3, 1, and point B is given to me as -1, 2. So when I plot the point A here, it would be somewhat here, point A. And then when I plot my point B here, it would be somewhat here. This would be my B vector, right? Now I have to plot points for different values of lambda, and that would be x here, right? You've already seen that when lambda takes a value 0, x takes a value equal to a. So for lambda equals to 0, I would be at point A itself. When lambda takes a value 1 here, x would be b, so x would be b. So I would be at point B itself. So this is point B. I would be at point B itself. Now let's see what happens when lambda takes a value 1 by 4, right? So when lambda takes a value 1 by 4, then x has to be equal to 3 by 4 times a plus, 3 by 4 times a plus 1 by 4 times b, right? So here it becomes 3 by 4 times 3, 1 plus 1 by 4 times -1, 2, which is nothing but 8 by 4, 5 by 4. So somewhat around 2, 5 by 4, right? So the point would be somewhat here, right? Now what happens when lambda takes a value? When lambda is half, then your x would be half of a plus half of b. That is half of 3, 1 plus half of -1, 2, which is nothing but 2 by 2, 3 by 2, which is 1, 1.5. So when I plot it here, it would be somewhere like this, right? Similarly, when lambda is 3 by 4, right, then I would get it as 1 by 4 times a plus 3 by 4 times b, which is 1 by 4 times 3, 1 plus 3 by 4 times -1, 2, which is 0 times 1 and then 7 by 4, right? So it would be somewhere here, right? So you can see that for different values of lambda, these are the points that I am getting on the axis, right? Now the second part of the question says that as lambda runs through all the real numbers between 0 and 1, what set of points does x trace out? Show that if lambda runs through all the real numbers, then x traces out the whole straight line 3, comma 1 and minus 1 comma 2. So they are saying here I have taken lambda के discrete cases कि lambda जब 0 था तब हम a point पे थे, जब lambda 1/4 हुआ तब यहाँ पहुँचे, जब lambda half हुआ then we reached here, and then when lambda became 1/4 we reached here, and then when lambda when lambda became 1 we were here. So it says that when lambda moves from 0 to 1, we can see that it traces out the entire line between A and B, right? So we can get the entire line. So the linear combination of lambda 1 minus lambda A plus lambda B here traces out the entire line between A and B here. So that is the question you had to show. You had to illustrate geometrically, right? So when lambda here takes a value between 0 and 1, you trace out the entire line between A and B. So these are some of the type of questions that are given in your exercise, right? You can try those questions. Those are based on the topics that we have done till now, right? So that is it for the first lecture on vectors. I hope you were able to follow whatever we have done till here in the class. After this, we will be starting with 12.4 from your chapter 12. That would be the scalar product of vectors and so on. And then we'll be doing that in the coming chapters. Thank you for watching the lecture. Thank you.